An object moving at a speed of 5 meters per second at point A goes off a cliff and is headed towards the water that is 17 meters below. The object falls to point B. Ignore air resistance. Number 1. What is the horizontal velocity at point A? Number 2. What is the vertical velocity at point A? Number 3. What is the horizontal velocity at point B? Number 4. What is the vertical velocity at point B? And now we have something at the 200 level. What is the heading of the velocity vector at point B? And number 6. What is the magnitude of the velocity vector at point B? So we have something coming off the edge at 5 meters per second. So initially it is completely along positive x. So you define positive x and positive y. X with the hat is the direction. Y with the hat is the direction. Initially, the velocity vector at point A is 100% along horizontal positive x. It falls like this. It falls like that, and point B is 17 meters below point A. So on this line, potential energy is 0 on that line. So question number 1, what is the horizontal velocity at point A? It's 5 meters per second along positive x. Question number 2, what is the vertical velocity at point A? The object is moving initially along positive x at 5 meters per second. So what is the vertical velocity? It is 0. The vertical component of the velocity vector at point A is equal to 0. The horizontal component of the velocity vector at point A is equal to 5 meters per second. The vertical component is 0. How about question number 3? When you have something that is falling like that, remember, initially it has 5 meters per second at point A. As it falls, its horizontal velocity of 5 meters per second stays the same at all points. So even at point B, the horizontal velocity at point B stays the same at 5 meters per second. Why? At point A, we had 5 meters per second as the horizontal speed, because the horizontal speed is unaffected by gravity, acceleration due to gravity. It will remain at 5 meters per second. What is the horizontal component of the velocity vector at point B? It is 5 meters per second along positive x. Question number 4 is, what is the vertical component of the velocity vector at point B? So you say total energy at A, total mechanical energy at A equals total mechanical energy at B. Total mechanical energy at A is kinetic energy at A plus potential energy at A. Total mechanical energy at B is kinetic energy at B plus potential energy at B. Kinetic energy at A, it is 1/2 m speed at point A squared, plus potential energy at A is mg times height of point A from the 0 level that we chose. Kinetic energy at B is 1/2 m. It is VB squared. Potential energy at B is mg times 0. So this whole thing goes to 0. Why? Because 0 times anything is 0. Now, do not forget, velocity at point A has just x component. That is not the same at point B. Velocity at B has x component and y component. So what is the magnitude of the velocity at point B? It is vbx squared plus vby squared. And the whole thing raised to the power of 1/2 or square root. So when you take the square of vb, what do we get? Vb squared is equal to vbx squared plus vby squared. So kinetic energy at B is 1/2 m vb squared, and vb squared has x squared plus y squared, vbx squared and vby squared. We know what is vbx. It is phi squared. So this is phi squared plus vby squared. So we substitute that. So 1/2 m, what is velocity at point A squared? It is 5 squared. Plus mg times height of point A is 17. 1/2 m vb squared is phi squared plus vby squared. Again, m appears everywhere, so divide both sides by m and multiply both sides by 2. So let's do one step at a time. When we divide by mass, we get phi squared divided by 2 plus g times 17 equals 1/2 times phi squared plus vby squared. So phi squared over 2 plus g times 17 equals 1/2 phi squared plus vby squared. We have division by 2, so we multiply both sides by 2. When you multiply by 2, you get phi squared plus 2 times g times 17 equals phi squared plus vby squared. Immediately you see that phi squared and phi squared is 25, so we get 25 on both sides, so we can subtract 25 from both sides, and what do we get? 2 times g times 17 equals vby squared. So substitute the numbers we know. 2 times 9.8 times 17 is equal to vby squared. So what is vby? Square root of 2 times 9.8 times 17. So what do we get? 18.25 meters per second. The magnitude is 18.25. The unit is meters per second. What is the direction? Definitely it is moving down, so it is along negative y. Negative y. So let's just review what we did so far. At point A, it has non-zero kinetic energy at the start. Vertical position of point A is 17 meters above the zero level. It has potential energy at the start. So it has kinetic energy and potential energy at the start. At point B, horizontal speed is unaffected by gravitational force along the vertical. Horizontal speed at point B is 5 meters per second, remains unchanged. Vertical speed at B is non-zero. We need to find that. We already found it, but we are just reviewing the notes again. So it is moving at point B. That makes the kinetic energy non-zero at point B. We have one thing working for us. Potential energy at point B, we set that to 0. Total mechanical energy at point A equal to total mechanical energy at point B. Substitute for kinetic energy at A, substitute for potential energy at A, substitute for kinetic energy at B, substitute for potential energy at B. Cancel mass, multiply both sides by 2 to get rid of division, and we get, then from there we substitute magnitude of the velocity at A squared is this, and magnitude of the velocity at B squared is this. We know Vax is 5, and that is equal to Vbx. We know Vay is 0. So you substitute for everything that we know. We know Vax, we know Vay is 0, we know acceleration due to gravity is 9.8, we know height of point A is 17, we know Vbx is the same as Vax, and that is the same as 5. We don't know. We know 9.8, and this is equal to 0 because height of point B is equal to 0. Height of point B is 0. Substitute everything and we get 18.25 meters per second. Y component of the velocity vector at point B. Magnitude is 18.25. Unit is meters per second. The direction is along negative y. It is pointing down. So here is our positive x and here is our positive y. So we have the x and the y velocity components at this point. What is the x component? 5. What is the y component? 18.25. So how do we get the magnitude of the velocity vector at point B? It is v squared is equal to vb squared is equal to vbx squared plus vby squared. Substitute those numbers that we know. We know vbx is 5. We know vby is 18.25. And we get 18.93 meters per second. To find the angle of the vector, now we know that at point B, the x velocity is 5. The y velocity is pointing down, and it is 18.25. You join these 2 points and measure this angle. And that is theta. And you know that tan theta is opposite side to theta divided by adjacent side to theta. What is the opposite side to theta? It is 18.25. So that is that, 18.25. What is the adjacent side to theta? Adjacent side to theta is 5. So that is this. When you do that, you get 74.68 degrees. So what is 74.68 degrees? It is the angle with respect to positive x. So what do we have? We have, what is the horizontal velocity at point A? 5. What is the vertical velocity at point A? 0. What is the horizontal velocity at point B? 5. What is the vertical velocity at point B? 18.25. What is the heading of the velocity vector? 74.68 degrees below the horizontal. Below the horizontal. What is the magnitude of the velocity vector at point B? 18.93 meters per second. What is the magnitude of the velocity vector at point B? 18.93 meters per second. And this is George Mathew, and I wish you good luck.